The universe is a vast, nearly incomprehensible expanse that contains everything in existence: space, time, matter, and energy. When we talk about the observable universe, we're referring to the portion of the universe that we can observe from Earth, based on the limitation of the speed of light. This observable universe is estimated to be about 93 billion light-years in diameter. To understand this, it's important to grasp that the universe has been expanding since the Big Bang, which occurred approximately 13.8 billion years ago. Because light has a finite speed, we can only observe objects whose light has had enough time to reach us since the universe began. However, due to the expansion of the universe, the objects we can see today were much closer when the light we now observe was emitted. Over time, the universe has continued to stretch, so the actual distance to these objects is now much greater than 13.8 billion light-years. The observable universe contains an estimated 2 trillion galaxies, each containing hundreds of billions of stars. Some estimates even suggest there could be as many as 10 trillion galaxies. Each star may host planets, and potentially, billions of those planets could harbor conditions suitable for life. The sheer numbers involved are staggering and almost impossible to comprehend fully. Imagine, for instance, the Milky Way galaxy, which is our cosmic home. The Milky Way alone is about 100,000 light-years in diameter and contains roughly 100 to 400 billion stars. It's a barred spiral galaxy, one of the many types of galaxies in the universe. Now, consider that the Milky Way is just one of potentially trillions of galaxies, each with its unique properties and populations of stars and planets. The diversity and abundance of galaxies hint at the immense complexity and variety in the universe. On a larger scale, galaxies are not evenly distributed throughout the universe. Instead, they form massive structures like clusters, superclusters, and vast voids. The largest known structures are superclusters of galaxies, which can span hundreds of millions of light-years. For example, the Laniakea supercluster, which includes the Milky Way, is about 520 million light-years across and contains roughly 100,000 galaxies. Even more mind-boggling are the Great Walls and Filaments, which are vast, thread-like structures that connect clusters of galaxies and define the large-scale structure of the universe. The Sloan Great Wall, for instance, is a cosmic structure 1.4 billion light-years in length. These structures are interconnected by immense voids, empty regions of space where very few galaxies exist. These voids can be tens to hundreds of millions of light-years across. One of the most profound discoveries in cosmology is that the universe is expanding. This was first observed by Edwin Hubble in the 1920s when he noticed that distant galaxies were moving away from us, with their light shifted to the red end of the spectrum, a phenomenon known as redshift. This discovery led to the formulation of Hubble's law, which states that the farther away a galaxy is, the faster it appears to be moving away from us. The expansion of the universe implies that, at one point, the universe was much smaller, denser, and hotter, leading to the concept of the Big Bang as the origin of the universe. The expansion isn't happening in any particular location. Rather, it's a property of space itself. Every point in the universe is moving away from every other point, meaning that the universe is expanding uniformly. Over time, this expansion is accelerating, driven by a mysterious force known as dark energy. Dark energy is thought to make up about 70% of the universe's total energy content and is causing galaxies to move away from each other at an increasing rate. The nature of dark energy is still one of the biggest mysteries in cosmology, and understanding it could reshape our knowledge of the universe. The universe is approximately 13.8 billion years old, a time frame that is difficult to imagine in human terms. To put this into perspective, consider the age of the Earth, which is about 4.5 billion years. The universe existed for nearly 9 billion years before our planet even formed. During that time, stars were born and died, galaxies formed and evolved, and the conditions for life as we know it began to emerge. In the earliest moments after the Big Bang, the universe was a hot, dense soup of elementary particles. As it expanded and cooled, these particles began to combine to form atoms, leading to the creation of the first hydrogen and helium atoms. These light elements eventually clumped together under gravity to form the first stars and galaxies, marking the beginning of the cosmic structure we see today. Another fascinating aspect of the universe is the concept of the cosmic horizon. Due to the finite speed of light and the expansion of the universe, there is a limit to how far we can see, the cosmic horizon. Beyond this horizon, the universe is so far away that light from those regions has not yet had time to reach us, and possibly never will, due to the accelerating expansion of space. This means that the observable universe is just a small fraction of the entire universe. The regions beyond the cosmic horizon remain a mystery and may contain even more galaxies, stars, and planets. The total size of the universe could be infinite, or it could be finite but unbounded, like the surface of a sphere. We simply don't know, and this adds to the wonder and mystery of space. The immensity of the universe raises profound questions about the possibility of life beyond Earth. Given the vast number of stars and planets, many of which may reside in the habitable zones of their respective stars, it seems statistically likely that life could exist elsewhere in the universe. However, the distances between stars and galaxies are so immense that communicating or traveling between them presents significant challenges. Humanity's exploration of the universe is still in its infancy. We've sent Voyager spacecraft to the edge of our solar system, and telescopes like the Hubble Space Telescope and the James Webb Space Telescope allow us to peer into the distant reaches of the universe. However, even with these incredible tools, we have only begun to scratch the surface of understanding the cosmos. In the future, advances in technology may allow us to explore the universe more thoroughly. Concepts like warp drives or wormholes, which are currently theoretical, could one day enable faster-than-light travel, allowing us to explore distant stars and galaxies. The search for extraterrestrial life, through missions to other planets and moons in our solar system and the detection of biosignatures on exoplanets, continues to be a major focus of scientific research. The immensity of the universe has a profound psychological and philosophical impact. It challenges our understanding of our place in the cosmos and forces us to confront the possibility that Earth is just one of countless planets in an unimaginably vast universe. This realization can be both humbling and awe-inspiring, leading to a deeper appreciation of the complexity and beauty of the universe. Philosophers and scientists alike have long pondered the implications of the universe's vastness. It raises questions about the nature of existence, the possibility of a multiverse, where multiple or infinite universes exist, and the ultimate fate of the cosmos. The contemplation of these ideas can lead to a sense of cosmic perspective, where the problems and concerns of daily life seem small in comparison to the grandeur of the universe. In summary, the immensity of the universe is one of the most incredible and awe-inspiring facts about space. It encompasses everything from the vast distances between galaxies to the possibility of life beyond Earth. The universe's scale, structure, and expansion challenge our understanding of reality and inspire a sense of wonder and curiosity about the cosmos.